Now, this video discusses on how we can calculate the number of moles. And by the way, if we say a mole, that is the amount of substance that contains the Avogadro number, which is given as 6.023 times 10 to the power positive 23. So which means actually a particular 1 mole, it contains 6.023 times 10 to the power 23 can be particles, can be atoms, can be molecules, can be ions, can be whatever for a given actual substance. So if we say a mole, that simply means the amount of substance that contains the Avogadro's number, that is 6.023 times 10 to the positive 23. So this is the same as the way we express it as, let's say 2 dozens. So two dozens corresponds to 2 times 12. Let's say if we say 1 unit, that corresponds to 10. That is 10 times 1 can be given as 10. If we say a 1 pair, that corresponds to actually 2. And I can say a 1 dozen, that corresponds to 12. So that's how you start to understand about the mole. So 1 mole corresponds to the Avogadro number, which is 6.023 times 10 to the positive 23. And let's say given a substance. Now, how can we be able to have the number of moles whenever the substance has been given? Now, the number of moles is given as the mass, mass given, of which the mass has to be in grams, and divided by, the relative atomic mass, which is said to be the LAM. And the LAM has to be in grams per mole. And how do we calculate the LAM? The LAM is calculated the same way the relative formula mass is calculated. So the LAM is the same as the relative formula mass of a compound, and only that the LAM has to be given the grams per mole. But the way we calculate the LAM, it is the same way we calculate the relative formula mass. Understand, how to calculate the relative formula mass of a compound. And in case you are not much aware about that one, just have to refer to my video playlist to come across all those. And I'll also, put the link in the comment section below for you to have that particular context. Now find the number of moles of the following actually substances. Let's say we have 2 grams of carbon dioxide. So how should you have the number of moles in 2 grams of carbon dioxide? We should have to understand that the mass has been given as 2 kgs, actually 2 grams, as per expected in terms of units. And what we need to have is LAM. So what is the LAM of carbon dioxide? So we calculate the LAM the way we calculate the relative formula mass of a compound, in the sense that how many atoms of carbon are there? We have it as 1. And what is the mass of the single carbon? That is 12. So we use 12. And of course, in some cases we use the decimal number, but for the sake of interest, we just have to use the 12. Or given the typical exams, you need to use the value that have been given as the LAM of a given element. So have it as 12 plus, and we have 2 atoms of oxygen, that is 2. And what is the mass of oxygen atom? That is 16. So have 16 like that. So what is 1 times 12? That is 12. And 16 times 2, that is 32. Now what is 12 plus 32? So with our beautiful calculators, we can be able to have that one. By the way, it has to be in overall units, that is grams per mole. So have it in grams per mole. We should have that. So that is 12 plus 32. That will be given as 44 grams per mole. We'll have 44 grams per mole. That is the lamb. Then how should you have the number of moles? We'll have it as 2 grams divided by 44 grams per mole, of which the grams will cancel. We'll have it as 2 divided by 44, that is 0.045 moles. So that's how the number of moles will be calculated, and for that given case. And how about, let's say, if we have 11 grams of, let's say, sodium oxide? How should you have the number of moles if that is the case? So mass has been given as 11 grams as per expected in terms of units. So the number of moles, that's what we are looking for, but we need the lamb. So what is the lamb of the sodium oxide? So we have the 1 mole of sodium. In the terms, what is the mass of a sodium? That is 23. In the times, we have 1 times 16. So we have 23 plus 16. What is 23 plus 16? So 23 plus 16, that will be given as 39. So by the way, we should have it in grams per mole. So we have that one in grams per mole. So we have the lamb, which is given as 39 grams per mole. So that is the lamb, and from there you can be able to have the number of moles, which is mass divided by the lamb. You have it there. And how about, let's say, if we have something like this? Let's say if we can have, should be 5 kgs of, let's say, nitrogen oxide. Now we have 5 grams of sodium, actually nitrogen oxide. So in this case we have the mass, which is given in grams, actually kilograms, that is in kgs, but we should have that in grams. So what you should have to understand is we just have to multiply this one by 1000. That will be given as 5000 grams. And what is the lamb of nitrogen oxide? We have 1 times 14, because the lamb for nitrogen is 14, and the plus 1 times 16. So make sure you understand about the relative atomic mass for each element. Of course, in a typical exams, everything is given. So you have 14 and plus 16, that is in grams per mole. So what is 14 plus 16? Now 14, plus is 16. That should be 14 plus 16. That is given as 30. So we have 30 grams per mole, and from there you can be able to have the number of moles. And what if we have, let's say, the number of moles? How should you have the mass? So let's say we need to find the mass that contains the following number of moles. Let's say 0.7 moles of, let's say, carbon monoxide. So we've been given the number of moles, that is 0.7 moles, and we need to have the mass. So how do you think we should have the mass? Now the formula for the number of moles is given as mass over lamb, of which you just have to make mass as a substitute to have mass is equal to number of moles times the lamb. Now the number of moles being given this, and we have the lamb of carbon monoxide. What is the lamb for the carbon monoxide? So the lamb will be given as, we have the single atom of carbon, that is 1 times, should be 12, and a plus 1 times 16. That will be given as 12 plus 16. So what is 12 plus 16? What would be that? So 12 plus 16, that is 28. So I have 28 grams per mole. that will be that. And the mass will be given as 0.7. That should be 0.7 moles, and times 28 grams per mole, of which moles will cancel, just have 0.7, times 28, have it in grams. So that's how you have that one. And also try to have the following and see how you can have it. Let's say we have a 10 moles of, let's say, sodium hydroxide, and let's say we have five more of, let's say, sulfur dioxide, and let's say we have should be 20 moles of let's say carbonate, and let's say we have 1.7 more of magnesium oxide. So try to have the mass number and for the given number of moles, and also try to have the number of moles for the given masses below. Right, so we need to have the mass, we need to have the moles given the following masses. Let's say we have 0.7 kgs of let's say HCl, that is hydrochloric acid, so that is hydrogen chloride. And let's say if we have 0.10 milligram, how should you have to change milligram to gram? You see that one. Let's say carbon dioxide, we should have that on, and let's say we should have, should be 10 grams of, should be kilograms rather, should be kilograms. Those, or 10 kgs of, there should be something about sodium hydroxide. So try to have the number of moles for these masses. Thank you.